Hello, everybody. I'm John Levell. This is an introduction to a fairly new Eclipse project called Eclipse Amlen. I'm the project lead for Amlen. Before there was an Amlen, I was the lead architect for an IBM product that IBM donated to Eclipse to form the basis of Amlen. I'm also on the technical committee for a protocol called MQTT that we'll talk about quite a bit in this talk, I expect. Before we get going, can I ask how many people had heard of Eclipse Amlen before this week? Quite a few, but we've definitely got some potential new recruits here. How many people had used Amlen before this week? Oh, we've got lots of new recruits. That's good. How about MQTT? Had people heard of MQTT before this week? Raise your hand if you'd heard of MQTT. Okay, I won't explain what MQTT is then. And of those people, how many had used MQTT? Okay, so yeah, we're quite knowledgeable about MQTT, but Amlen is fairly new to quite a few people. So it's easy to describe what Amlen is. Amlen is a message broker. It is designed to sit between the big wide world. Out here, anything that's sitting outside your enterprise and applications running in a cloud or in a data center, bidirectional communication. I sometimes refer to it as an MQTT broker. That is a little bit unfair because it can do other protocols. There's a JMS API with its own protocol, and you can put plugins into Amlen that do other protocols. But the majority of our customers use MQTT, and when they're not using MQTT, often people use gateways. So you have some devices talking up to a gateway that then talks MQTT up to Amlen. So most of the time, Amlen is used for MQTT. It's designed to talk to very large numbers of devices often. If you're looking for an MQTT broker to put inside your washing machine, then there are definitely better things on the market out there. If you're trying to connect thousands or millions of washing machines up to applications in the cloud or in a data center, then Amlen might well be useful to you. I should mention that Amlen is Welsh for envelope. I actually chose the name Amlen. I was a bit surprised when we were going to donate the IBM product to Eclipse. They asked what we should call it and said it was a name that shouldn't have technical relation to its function and was easy to trademark. And I sort of picked Amlen because it's Welsh for envelope, and Amlen protects your messages in between the sender sending them and the receiver receiving them. But I thought it would go through lots of process and senior people would decide what to call it. Marketing folks in IBM, that kind of thing, but the name seems to have stuck, which is good. So here's a highly technical drawing of a cloud. You have things on the left here. Quite often Amlen is used when you have not typical IoT use cases, but where you have a human using a device. So that can be a web browser or a mobile phone. So for example, for many years, the predecessor of Amlen was used for the Wimbledon tennis tournaments. You have a mobile phone app, and as each point is scored in Wimbledon, you got an update, and those updates go over MQTT to the mobile phone app. Through Amlen, you often get Amlen in pairs, and I'll talk about why later. And I just want to mention a couple of other Eclipse projects. I really don't want to try and do a list of all Eclipse projects related to IoT or even related to MQTT, because I'll forget somebody and I'll feel bad. But there are two I want to mention. There is Eclipse Paho, which is a collection of MQTT clients for different languages. So if you want a client to talk to Amlen in C or in Java or in Python, or the list goes on. then often Eclipse Paho is a good place to get a client from. It's not the only place. There are lots of clients that are not in Paho, and as long as they speak either MQTT version 3 or MQTT version 5, then you can use those clients to talk to Amlen. Version 3 is the sort of older, simpler version of MQTT. Version 5 is a sort of newer protocol with more features, and Amlen speaks them both. And I'm happy, if people want me to talk a little bit about the differences between those two protocols. So I said we're a new project. In 2022, we released our first version, 1.0. So that was a very major milestone for the product. The version number is a little bit misleading, though. Like I say, it was based on a donation of a mature code base. So we do have customers running in production large workloads on Amlen 1.0. So where is it used? I have yet to get customers to say I can put their logos on slides yet. I'm working on that. So I'll just talk in general terms about the industries. It is used widely in the automotive industry. And different car companies have used it for different things. So sometimes it's used between the car and the cloud or a data center for sending information either way, often sensor readings from cars, that kind of thing. But it's also used in factories. So if you think of a factory, it's got a lot of very complicated machinery, and lots of that machinery is putting out a lot of sensor data, and you can send that via MQTT through Amlen and then analyze the data and check your factory is running well. But as I say, it's not always traditional IoT. If you're a bank, you might be nervous about sending a push notification to somebody saying that they're wildly overdrawn and need to pay in lots of money. So often they have an app on their phone, and you can send them send the customer a notification to log into the app to make a secure MQTT connection that then you can be more comfortable sending financial information down. When we talk about IoT, perhaps not people in this room, but people out in the big wide world often think about things like smart fridges. White goods are a good place where you might use MQTT, not just because that allows a customer to have an app on their phone that means they can start their washing machine, but the key reason, I think, why manufacturers tend to like that kind of thing is because it allows them to get diagnostics. If you are a lift manufacturer and one of your lifts goes wrong, then they're very keen to reduce the average number of times that somebody has to visit that lift to repair it. So if the first time the guy or the girl comes out in the van and looks at the lift and they don't have the right part, then they have to go away, they have to find the part, and they have to come back, and that lift is out of order for longer. Whereas if they've got a bunch of diagnostics from the lift, the first time that somebody turns up in a van, they've got all the right parts on the van, the lift is back into operation faster, so it has a higher uptime, and the customer is more satisfied. So I've said that Amlen is an MQTT broker, a message broker, but I haven't really said what it is. It's a piece of very standard Linux software. Currently, we package it for sort of Red Hat-derived distributions, all the way from RHEL 7 era distributions to RHEL 9 era and Fedora. But we are definitely looking for volunteers to package it for other distributions. We did have somebody start to package it for Ubuntu, but they haven't finished that. So that is something that we plan to do. We also ship an example Docker file to show how you can put it into a container. It's fairly standard, but it is stateful. So if you're putting it into a container inside Kubernetes, you need to use things like stateful sets and think about persistent volumes, which makes things harder than if it's stateless. So we've talked about Amlen as a broker, but there are other components to Amlen. There is a web UI where you can see how the server component is performing. You can monitor it. You can drill down and see what subscriptions and how many messages each subscriber is receiving, that kind of thing. But you can also configure servers that way, and the web UI is effectively a separate install, and one web UI can monitor and control lots of server instances. And under the covers, the web UI is just using the REST interface of the server. So anything you can do in this user interface, you can automate as well. But now I've put you all to sleep, let me instead do a demo. So if you have a laptop or a phone, coralbark.net is my homepage, and on there I have put a tiny little, I have apparently closed the window. Oh no, there it is. I've put a tiny little JavaScript application it's hard to drive the I'm trying to get this over there so people can see the URL. So I've used this demo before, and so far the audiences have been mature enough not to make me embarrassed about what's on the screen, but please don't write rude words in any language. Up the top here, you can see that you can change the color of your pen and stuff. I'm happy to show people, well, you can look yourself, view source. The amount of JavaScript in this little demo is tiny. It's a couple of pages. Actually, in the resolution of this screen, I think it's 4 pages long. But it's very easy with Amlen, or with MQTT in general, to write applications very quickly and easily. And I hope you should see, if the internet is up to scratch, that the latency between your phone and the screen up here is good. If I now try and bring if I can find my mouse pointer, the web UI from Amlen, and log in. We can see how many people are out there in the audience, and how many messages a second. We were peaking at 1,000 messages a second. Nothing very exciting, and we're only down at 16 messages a second now. If this was slightly differently configured, I'd try and have a wander around the web UI and drill into looking at individual subscriptions and things, but it's sort of really hard for me to see the screen up there and my laptop at the same time, so I think I'll just move on and talk about it in slide form. Okay. So, as I said, in that web UI, you could just see you can configure things as well as monitor things. So you set up policies to define security levels, so you can say on a particular topic, this group of people are allowed to subscribe or are allowed to publish. And actually, a anti-pattern I sometimes see with customers with Fedora, with Amlen, is that people think, okay, I'm going to have 1,000 devices or 10,000 devices or 1,000,000 devices. Therefore, I need 1,000 policies or 10,000 policies or 1,000,000 policies. And that is not how it's designed at all. That would be a real anti-pattern for Amlen. You can put into these fields, like the topic, variables like user IDs. So if I say that in a policy that a certain LDAP group is allowed to subscribe to a destination like /messages/user ID, then if my username is Bob, I can subscribe to /messages/Bob, and a different user might be allowed to subscribe to /messages/Fred, but you don't try and make policies per user. You have 1 or 2 policies, and that can apply to 1,000 users or 10,000 users or 1 million users. Earlier at the start of the talk, I mentioned that Amlen is often used in pairs. It is very often used in pairs. When you send data to Amlen, if it's used in a pair, it's sort of an active-passive system where the passive system is sort of warm and ready to take over. But when a message arrives at the primary, it's sent to the secondary, and the primary receives an acknowledgement before the sender receives an acknowledgement. So if you're trying to do a reliable message and you send a message to Amlen and you get an acknowledgement back, you know that that message is recorded by both servers, and you can trust that they have it. We spent a lot of time on the performance of these HA pairs because both servers have to acknowledge that they have the message before the publisher is told. As you separate the servers in network terms, add more and more latency, then the latency of messages going through the system is bound to increase. But even if you have the servers on different continents, separated in very different availability zones, different regions, then the throughput, a number of messages, doesn't change. It stays pleasingly constant, even as you separate the HA pairs. So the latency, the time it takes an individual message to go through the system goes up because it has to go into the first server, across to the other server and back before going on to the subscribers. But the amount of messages going through the system, the number of messages per second, stays relatively constant. And you can configure what happens if the 2 servers have a network split and then rejoin. By default, the configuration is basically, well, if they've both been running independently and have sent and received messages, then when they rejoin, they don't know as a pair which version of the world to take, and split brain, and a human needs to decide. But there is also a method where effectively the load balancers sitting in front of the servers can act as a tiebreaker, and whichever system has the most connections wins, and the other server becomes a secondary. So HA pairs are used whenever you've got durable data. So if you've got clients that are buffering messages on a server when they're disconnected, so any durable, persistent messages tend to mean that you want an HA pair. You can also cluster Amlens together. And I would say I see customers underuse HA pairs and overuse clusters. So because clusters, they're not for the same thing at all. HA pairs are for reliability, whereas clusters are for scalability. So with a cluster, you add this blue link between the servers so that a subscriber up here on the top Amlen can receive messages published on the bottom Amlen, and they flow over these links between servers. So people might, if they've not used Amlen very much before, think, I want multiple servers. I will just use a cluster and I won't use HA pairs. But they're for different things. We're very protective of this link because we want the system to scale well. We try and send as few messages as possible across this link between servers. So if you have subscribers here and publishers here, but no subscribers down here, then we won't send the message down this link. So you can't have durable messages buffered on one server and think, well, if that server dies, the messages will still be somewhere in the cluster. You need HA pairs for that. Because we want, as you add more servers, the system as a whole to scale well. If there's no link at all, and you can partition your devices across the Amlen servers, then you know each time you add a new pair of Amlen servers, that will add as much capacity as the first Amlen pair added. Whereas if nearly all your messages flow across this link, then adding another pair of servers doesn't add very much, because it has to process all the messages that the other servers are already processing as well. So I actually ask people who are using Amlen to think whether they really need a cluster at all, or whether they can partition their devices across servers and have a back-end instance of the application connected to each Amlen. And then if you don't need a cluster at all, you know that the system will scale really well as you add more servers. If you are doing the sort of typical IoT use case where you have devices out here going to back-end applications, and you can just have instances on each Amlen, then often you don't need a cluster. For other use cases, so we've seen people build instant messaging systems on top of Amlen, where effectively any device, which is usually a mobile phone, can publish messages to go to any other device. Then you need to have a cluster so that messages can flow from anywhere to anywhere. But people often use them by default, and I would argue you need to think about whether you use them. So we've talked about the server, we've talked about the web UI, and I've talked a little bit about scaling and reliability for Amlen. There's also one more component I want to talk about, which is a bridge. The bridge is effectively a simple program that can subscribe or have lots of instances of it subscribe to a shared subscription on one Amlen, publishing somewhere else, and it can be bidirectional. So you can use this to make networks of Amlen servers where only some fraction of the messages on this server are forwarded up to a different Amlen in the cloud somewhere. You can use it. There's nothing special about Amlen in this sense. You can use it to connect between Amlen and some other MQTT system. We quite often see Amlen used with Mosquito, where you have Mosquito, which is a very small, lightweight MQTT broker running, say, in a washing machine, talking up to Amlen. And you could use the Amlen bridge for that connection, but actually we tend to see that in that case, the Mosquito can do that forwarding itself. This also allows you to send messages on to Kafka and change the topic string. So if the message is arriving at server 1 on topic A, they can be forwarded to topic B on a different server. And if you're using MQTT5, there is something called message properties, sort of metadata that you can set to go with a message. And the bridge can filter out messages based on that. Sorry, wrong button. We have a performance report down here. Single instances tend to have hundreds of thousands at maximum connections. We do tests in the performance report where instances have millions of clients. But I don't tend to see that in production. I tend to think in production, customers will have maybe a few 100,000 clients connected to a single instance at most. And again, hundreds of thousands of messages a second per instance. Again, in the performance report, you'll see that with a big instance, you can do millions of messages a second. But again, I don't expect that to be how it's used in production. So I just wanted to summarize where we got to so far. So this year we did our 1.0 release. There are now multiple companies who offer paid support for Amlen. And actually, while I've been at this conference, a third company has come and talked to me about perhaps adding themselves to that list. The old IBM product that Amlen was originally based on went end of life, so I've spent a lot of my year talking to worried customers and explaining to them that it's okay and Amlen will be the way forward, and helping them migrate to Amlen. I do know that Amlen is in use in production by a number of companies at very large scale. And klaxon warning, a word from our sponsors. I am paid full-time by IBM to work on this stuff, and the reason that IBM pay me is that Amlen is used as in a component by a number of different IBM software, but the key thing that actually pays my bills is called Maximo Application Suite. Maximo Application Suite is a collection of software that runs on top of OpenShift that does things like monitor IoT devices, analyze data from IoT devices, and do AI-type things, and sort of catalog your assets, that kind of thing. And under the covers, the IoT connectivity for that suite is based on Amlen. Okay, advert over. So what are we doing in the future? We are currently working on a Kubernetes operator. I said that Amlen is often used in Kubernetes. It would be easier if we had an operator that automatically deployed it, that helped you deploy it. So you could scale up the number of HA pairs, that kind of thing. We're working on that. I'd hope to get the 1.1 release out about now, but we're not there yet. So perhaps towards the end of the year or very early next year. We really do need to improve our documentation. We have lots of documentation, but it's quite dry, quite heavy. It lists all the options. It's good for reference, but it's not good for getting going quickly. I've started to write a series of blog posts that just sort of say, I think you should do it like this, even though there are other ways to do it. And the first few of those are out, but there will be more. And once we've done the 1.1 release, which has some tidy ups, I do want to start submitting this upstream to Linux distributions. Probably only the server component, because the other components tend to have lots of dependencies that will be hard to package. But the MQTT server itself, I would like to see in distributions. We want help. Please help us. If you're experienced users, we'd love to see your tutorials and guides. We have a website. I wrote it. It's not very good. We'd love people to work on that. I'm sure every open source project would love more programmers. And as I mentioned, people who would be happy to package this for other Linux distributions would be very welcome to help us. I've stuck a complicated slide showing the architecture of the system in the deck here. I don't think I'll say very much about this, just that the server component is written in C, although you can have plugins written in Java for different protocols. And then the web UI is written in Java and JavaScript. I think I'll stop there, though, and allow a little bit of time for questions once I've done some plugs for this is the main official website. If you want to get straight into the source code, there we are on GitHub. We have a Slack channel that is actually where I encourage people to talk to us, although I think old habits die hard and lots of people email me. But please do come and join our Slack channel and ask questions and discuss it. And this is the blog where a number of contributors are starting to put posts about things that are new and how to get going in Amlen. Okay, thank you very much, guys. Are there any questions? Hang on, sorry. I'm sure you can shout, but I think this is being recorded. I don't know whether this is on.
So about the bridge, does it support any kind of buffering if the upstream connection goes down? And how much resources does it usually consume?
No, it doesn't support any form of buffering. So the question was the Amlen bridge Does it support buffering? No, it's effectively a set of subscriber applications and publisher applications stuck back to back. So if one connection or the other breaks, messages stop flowing, but it will stop doing acknowledgements. So when the connections re-establish, it will carry on. It's a very simple piece of software. And resources, it takes very little RAM because it is just two MQTT clients stuck, welded together. C. Lovely. That would be good. Yes, no, I don't have people to help there. I have packaged things for Fedora in the past myself, but yes, I'm still fairly inexperienced at it, so I'd love your help. Thank you. Other questions? In that case, I think we're done, guys. Thank you very much.